Quiz number 2. I'll go over the answers to this after I read all of them. I guess I don't know exactly how to do this, but I'll just see what happens. By looking at the Earth, which portion is the oldest? D, C, B, or A? A is the crust, B is the mantle, C is the outer core, D is the inner core. What is the principle of superposition? Rocks can form anywhere in outer space. Older rocks are usually found above younger ones. Younger rocks are usually found above older ones. Fossils can be found anywhere. And here's a layer, or a bunch of layers. Think of the Grand Canyon. Layers, top. This is the top of the surface of the rocks, and these are the layers of the Grand Canyon. Think of it like that. Which layer is the youngest, and which layer is the oldest? The thermal energy of 40 million Kelvin is equivalent to 1 electron volt, 200 electron volts, 10 kilo electron volts, 3.5 kilo electron volts, or 3.5 mega electron volts. What magnitude of energy is required for nuclear fusions to occur? Tens of eV, thousands of eV, keV, millions of eV, which is mega eV, or billions of eV, giga eV. What is the theoretical temperature, thermal energy in the core of the sun? 1 to 3.5 keV, 1 to 3.5 MeV, or 1 to 3.5 GeV, which is billions of electron volts. Or Florida asphalt on a sunny summer day. 17. Can the sun in its interior engage in fusion reactions? Yes or no? (18) What theoretical entity or process was invented by mathematicians to explain away the major fusion energy discrepancy in the sun? Quantum tunneling, fairies, Bigfoot using advanced alien processes to crush the sun internally. Where can fusion actually occur? In the imaginations of mathematicians, in AGNs, active galactic nuclei only, really big stars, or D, wherever the immense energies are available. 20. Which types of reactions and processes is stellar evolution dominated by? Nuclear processes, thermochemical, electrochemical, photochemical, electromechanical, electrodynamic, magnetodynamic, hydrodynamic. Magnetohydrodynamic, electromagnetohydrodynamic, or everything except A. Now I'll go over the answers with you guys. Of course, you can pause the video and go back to it. Alright. By looking at the Earth, which portion is the oldest? It's D, the inner core. As the star layers its interior, this is the portion that gets layered first inside the core of the star. That's why it's the oldest. And as it layers, it forms the planet in its interior. And A, the crust, is definitely the youngest portion. Keep that in mind when you look at mountains. Mountains are very, very, very young as opposed to the deeper regions of the Earth. As well, the basalt that's in the ocean basin, the bottom of the ocean, is also very young as well, as opposed to the central regions of the Earth. The central regions of the Earth are vastly older than the outer regions. And the principle of superposition is what I wanted to review here. The answer clearly is younger rocks are usually found above older ones. As materials formed, they layer, so the older rocks get layered on the bottom, and then successive layers on the top are younger and younger and younger. Of course, that's granted that they don't fold and change, and other rocks are sedimentated or layered on the top. it all depends. This is just a rule of thumb. You have to actually look at the features that you're studying. For instance, like you'll see mountains, okay? So of course the layers will be like this. But then when you weather away the top of the mountain, you'll have pieces of really old portions at the very bottom being higher than the young portions at the top. So you'll be like, well, this is supposed to be, the younger portion, but you got to keep that in mind. The older might be above the younger. Which layer is the youngest? This is pretty basic. We just went over that. The youngest is A. Which layer is the oldest? That would be F. F would be the oldest portion of this landmass. 14. A thermal energy of 40 million Kelvin is equivalent to 3.5 kilo electron volts, 3,500 electron volts. It's not that much. What magnitude of energy is required for nuclear transformation's fusion to occur? For fusion to occur, you need millions of eV. Notice what I did there. The interior of the sun. Oh, wait, we haven't got that here. Hang on here. 16. What is the theoretical temperature thermal energy in the core of the sun? 1 to 3.5 keV, 1 to 3.5 MeV, or 1 to 3.5 GeV. Clearly it's 1 to 3.5 keV. So it's about 15 million Kelvin. So what that means is we can answer the last question here. Can the sun and its interior engage in fusion reactions? No. The sun cannot engage in fusion reactions at all. It's not hot enough. That's very damaging because this actually wasn't something that I thought of myself. George Gamow itself, in a book called A Star Called the Sun, written by George Gamow. I'm not sure how you pronounce that, but page 127 if you want to see this information. Of course, I went online and I figured 40 million. I have 20 million. That's probably in Fahrenheit, but 40 million Kelvin is the correct. 40 million Kelvin is the correct number there. But if you want to verify that this information is correct, it's in this book. This guy was a nuclear physicist, and he literally writes down in the book, and anybody can read it, that the sun, its thermal energy is in thousands of eV, not the millions of eV required for fusion reactions to take place. That's very bad, which then leads us to our next realization. What theoretical entity or process was invented by mathematicians to explain away the major fusion energy discrepancy in the sun? Quantum tunneling, fairies, Bigfoot using advanced alien processes to crush the sun internally. We know this isn't true because Bigfoot is usually just a black bear or a brown bear walking around and on his hind legs, and it scares the crap out of people. Fairies, not too sure if those exist. I would bet that they didn't invent that. Quantum tunneling, I think this is what they invented to explain away the fusion energy discrepancy. And quantum tunneling basically is there's an energy that you have to reach above a certain point for a reaction to take place. So look at it like a hill. You have a particle over here. You have to reach this energy up here in order to go all the way back down the hill again to reach a higher energy state or whatever. So quantum tunneling says instead of using the required MeV to go all the way up to the top, what they do is say, oh no, since the sun isn't hot enough, we can just ignore this top hill right here. We'll just tunnel straight through and you know, we can do whatever we want now because we have math. But this is clearly nonsense. There's no such thing as quantum tunneling, no matter what they say. You need to have the energy there to get to the next level of energy, or the next energy state. You just can't ignore it and say it just tunnels through. That's a cop-out. Where can fusion actually occur? In the imaginations of mathematicians? No, we know it occurs because we have heavier and heavier elements, so fusion does occur. In AGNs, active galactic nuclei only, really big stars, wherever the immense energies are available. The immense energies, wherever the energies are available, that's where fusion is going to occur. But active galactic nuclei only, no, it happens wherever the energies are available. So it does happen in AGNs, but not that only. It also happens where the immense energies are available. Which types of reactions and processes is stellar evolution dominated by? Nuclear processes, thermochemical, it's actually K. Everything except A. And the reason why it's dominated by all these, because all of these are lower energy phenomenon. The very energetic phenomenon, the nuclear processes, happen in other places that have the energy required to have them occur. Most of stellar evolution involves all of these processes. Forgot to circle that too. Yeah, that's basically it, you guys. Today is February 27th, 2019.